Okay, so this slide right here shows some formulas that are used a lot. So this first one, this is temperature. This is turning Fahrenheit into Celsius. So if it's 80 degrees, you put it in right here for Fahrenheit, you crank it through and you get your Celsius right here. Another one is simple interest, I equals PRT. That's one that is used a lot. Okay, and this one we've actually already used in that Mississippi River problem. I don't know if you remember that. So that is distance equals rate times time. So let's see how we can finagle one of these. So here's the area of a triangle. A equals 1/2 base time height, and we want to solve for H. So what I'm going to do first is, well, what I really could do is I could just divide through by 1/2 B. That's what I could do. But instead of doing that, I think I'm going to get rid of that 1/2 first. And the way that you get rid of this 1/2 is you multiply both sides by 2. Because then what that does is it cancels out those 2's on that side. I have 2A equals BH. And then, because this is being multiplied, you undo multiplication with division. I'm going to divide both sides by B. So the height of a triangle is twice the area divided by the base. Okay. So this one's a little more complicated, and there are going to be a couple in your homework that might be tricky, but work with it. And just remember, of course, like I've said 100 times, and you're probably getting sick of hearing me say it, what you do to one side, you do the other side. Even if it's not the right thing, maybe you make it worse. I don't know, like you add something you shouldn't, but as long as you do it on one side and you do it on the other, you're good, and you can fix it along the way. Okay, so we're solving for F. We're going to get F by itself. And I'm going to start by getting rid of this fraction. So if I've got 5/9 there, I'm going to multiply both sides by its reciprocal. So if I multiply this by 9/5, okay, on both sides, then this becomes 45 over 45 really. But the 5's cancel, the 9's cancel, and I have 9/5 C equals F minus 32. Okay, then I just need to add 32 to both sides, and I get Fahrenheit is 9/5 Celsius plus 32. So if you're up in Canada and they're like, it's 40 degrees Celsius, and you can't figure out why it's so hot or whatever, if you plug that into this formula right here, it'll tell you what it is in Fahrenheit, which is what we're used to. Okay, so here's a question that goes along with this. I'm going to keep this formula right here. It says a fever is generally considered to be a body temperature greater than 100 degrees Fahrenheit. Your friend has a temperature of 37 degrees Celsius because your friend is Canadian. I'm just kidding. They're whatever, just not American. Okay, does your friend have a fever? Well, I'm going to plug it into this formula. So I've got F equals 9/5 times C, which is 37, plus 32. Okay, and once I put that in and I crank it out, I end up with 98.6 degrees, which is what they consider normal. So no, my friend does not have a fever. Thank goodness, because they might have COVID and that would be horrible. Okay, so one more I want you to try. Okay, so I'm going to keep this formula up here, but it says the surface temperature of the planet Mercury is 427 degrees Celsius. What is it in Fahrenheit? So go ahead and pause and try this one. Okay, so we do the same thing that we did before. We plug our Celsius into this right here. So we've got Fahrenheit equals 9/5 times 427 plus 32. And again, when I crank that out, I get 800.6 degrees. That is roasty toasty right there. I don't think anything on earth would, well, you wouldn't bake at that temperature, I'll just say that. Okay, so homework. Again, you guys, just remember, this homework is on bigideasmath.com. I just put it here just in case you want to look it up in your book. But your book assignment is in Big Ideas. I just don't want you to get confused. And one of the problems in the book dealt with Jupiter and Mercury, and I can't remember which is which. I think this is Jupiter, but these are just some really cool pictures, you know, when they put filters on the telescopes and stuff, but I think this is Jupiter and this is Mercury. They're just really cool looking. So as always, if you've got questions, you know how to get a hold of me. Thank you.